technology. So, as in the previous session, I'm going to start with a little bit of black. And the cloud is obviously the big trends, right? And if you believe all the people preaching the cloud, they say all the applications will move to the cloud. Everything moves to the cloud. We're all in, everything moves to the cloud. Is that true? Yeah, I have my doubts as well. No, they don't. So let's take a look at an app, or a bunch of apps. What we've been teaching developers and architects for the last 15 years is kind of this model, right? 15, 20 years ago, there were a lot of islands, and people were working with individual apps. And what we've done collectively, all of us, I'm sure some of you have worked on that as well, is to go and stitch all that stuff together so that there's seamless flow between those apps. So you can go and have, so I'm modeling this kind of after the applications that are inside of Microsoft. So we have a vendor market called MS Market, and MS Market interfaces with the ERP system. You have a benefits thing where you have employee benefits. That interacts with the vendor market. Travel is handled through the vendor market, and the vendor market itself interacts with the travel system. You have an employee shop, and that employee shop interacts with, or a public-facing shop, and that has a loyalty program model. The loyalty program interacts with the CRM system. There's BI that's looking across all those things. So there's a lot of subsystems, a lot of pieces that make up the infrastructure of an enterprise. And so we've been doing a lot of work, and many of you have, to go and integrate all these pieces. The reality is, though, that's all running in focused data centers, right? So Microsoft is running most of these things in data centers in Washington State. Centralized, that's where our SAP sits, that's where all of our internal systems sit. So now you see all this promise of there's the cloud. And it's actually cheaper to run many applications in the cloud because you don't need to manage all the infrastructure. Right? Patch management is done for you. You don't have to buy the machines. I mean, there's all this hardware management and cooling and power and all those things. So cloud is great for that. So a lot of CIOs see that promise, but they're also they know what they have and they know what they can trust. So there's nobody who moves into the cloud all along. So people try to do this, right? They either build their own system up here, or they outsource to someone else and say, yeah, you run my vendor market. So that's effectively where employees can go and buy stuff in a self-service fashion. Now, what we've done, and if you look at the Microsoft Intranet, for instance, but very many, all large organizations have that kind of thing. This thing it seems like it's a very easy thing to go and break out and host somewhere else, right? It's a web app. And all it does is it shows you a catalog and things, and then in the end comes out a transaction. But how does that transaction really work? And then there's really business logic that belongs to other systems, right? We could have travel sourcing sitting here, but then you really need to have a travel backend system that's specialized in, it's not just a marketplace. And once you actually have the order, then you need to go and put that into an ERP system. At least you need to have a notion of that order in your own system, and then you need to go and fan it out to the vendor system. So it's kind of difficult. So taking this app, or any of these apps, the cloud is kind of like tripping into some chewing gum on the street and trying to pull your foot up. Because it's got all these tethers hanging off it, which are all connectivity needs into that app. And of course, this is all the sacred core of the enterprise, which means people are not going to just go and make a hole in the firewall and just expose those services. At the same time, if you see this as if this is not a dedicated application, so it's not something that you build, but someone else builds for you or hosts for you, there's also not necessarily trust. So if you were just taking that application and you're moving it up to the cloud, to Windows Azure or to Amazon, that's the two viable large public cloud environments where you can host existing apps. Or Google App Engine is more something for new apps. If you do this, then you have the option of using a VPN kind of integration model if and only if you trust those apps. Because what does a VPN solution, like the one that Amazon offers and the one that we offer with Windows Azure Connect, what does that do? It goes and takes out of the large pool of machines that sit up in the cloud, it takes a number of those machines and joins them into a domain that you control. Which means now you get layer 2 network integration, but that means that you're trusting those 15 boxes. And you're mapping them into your network, which means you now don't have a multi-tenant system, but you really need to be in control of it. Let's field questions later. Also because we're taping that on video, so. But I'm happy to answer any questions. We're going to have a Q&A section at the end. So, if you have a software as a service application that you want to go and integrate here, really a VPN kind of integration is not a choice, but you still need to have that connectivity into the enterprise. So that's hard. Existing web services endpoint, for instance, you have new mutual trust, as I said, that sits behind this net and the firewall, and it's not built for non-corporate identity and access control. Very often these things are just controlled by roles and identities that are in Active Directory, but you rely on that security infrastructure be in place. And all of a sudden you have something that runs completely somewhere else in a completely different security context, and you need to go and knit those things together. So that's all very difficult to do. And so you see everybody wants to go to the cloud. You see that momentum building, but once people hit reality, they're like, wow, this is really difficult to do. So what we see is we see a lot of tactical little isolated apps which move up to the cloud, but really attacking the core of the enterprise is something that happens very rarely, and a lot of those people come to us to talk to us about Service Bus. It goes further than that. There are several places where we talk to customers who have special connectivity needs. Let me start with this here. This is an airport. Apparently during the Christmas season in Europe. And this is all about lines of people who stand behind counters and want to be checked in. This airline is EasyJet. EasyJet is a European airline. It's a low-cost airline. And so they've been thinking about their cloud story and their cloud infrastructure. And they made up a strategy. And the strategy was, we're going to embrace the cloud, and we will go non-essential services first, backup. Then we're going to go to the edges, marketing. We're going to outsource the marketing website. And it's going to take us forever to get to the core systems and to airside. Airside being, everything has to do with loading airplanes. That was the strategy in 2009, where they were thinking that's what they would do. The implementation that they ended up with was exactly the reverse. What they ended up with is starting with airside, starting really with the passengers, using technology that we gave them. So they're using Service Bus for the following scenario. They hate this picture. They hate those lines, and they also hate the expense of running their, you have agents at airports. If you fly, then you have those people, and they keep typing a lot. They're typing a lot on green screens because they're super complex systems that are built for the needs of major, huge airlines. KLM has large infrastructure. Lufthansa has large infrastructure. So those huge airlines have those infrastructures. And the smaller airlines, like EasyJet, basically rent that from them, rent those at the terminals. Now, EasyJet has a much simpler system because they don't have all those connections and they don't have those combinations. They have a simpler fare system. So for them, that system is overkill, but it costs them a lot of money. And they already have a way to go and check in customers through their EasyJet.com website. So they know how to build load manifests, they know how to build passenger manifests, they know how to build all the documentation that's needed that they owe all the authorities. So they said, why don't we just ditch all these terminal things and just run it on our own system? Now, they hadn't built that system that they have, EasyJet.com website, underneath a layer of web services, so nicely tiered. They hadn't built that layer for outside consumption. So now they were facing the question of whether they would take that layer and go and expose that out on their public edge and add security to it, etc. So that was the first thing. And the second thing is, what they wanted to do out in the sites is they wanted to have little handheld devices with sensors and readers and all those things, so that they can very easily go and basically take someone's credit card, because it has a name on it, swipe it, get the name. With that, they get the record. How heavy is your luggage? Weigh it, put the data in, be done, right? So check in much faster, exactly as EasyJet needs it. So, but as they load an airplane, they need to record and need to synchronize between the devices that 4 people have, how many people have been boarded, where they have been boarded, and all this. So they needed to have some kind of little queuing system to keep those systems in sync. So they were looking around and picked Service Bus, and they said, with Service Bus, we can do this. Because Service Bus does 2 things for them. So those guys were then looking at the technology, and so taking their internal web services that they built for the website, exposing them publicly so that into their core system, and we are their DMZ. So we are the demilitarized zone for the EasyJet backend systems. We provide them with a synchronization little set of queues that they use to go and synchronize across all their devices. It's perfect for them. More scenarios. In the house, there's a number of efforts that is going around smart homes and smart electricity grids. That's all motivated by new uses of the electricity that take a lot of power. One of the things that the electricity companies in Europe and in America, not so sure here, are really frightened of is the electric car. Because the electric car is going to cause something that's really interesting. Today, all the energy for cars comes out of tanks that are at gas stations. If the electric car actually takes off, that same amount of energy needs to come out of the wall plug, which means that the network, the electricity grid, is not built for that purpose. So now they're all thinking about smart ways for how to go and deal with that additional capacity demand, and the only thing they can think of right now is distribute the load. So what they're trying to do is effectively make the electricity less expensive on a region-by-region basis or on a block-by-block basis, so that they control when people go and charge their cars. So that's one of the drivers there. But the interesting thing is, how do you get that data into the house? Because now you have this device, right? The device determines when you charge things, but how do you get there? People have broadband, but maybe they're on WiMAX. Maybe they're on some technology that doesn't give you a public IP address, because many places in the world, I don't know how it is here, but I would be guessing that in a place as busy as here, there's a bunch of ISPs here where you just get a NAT address, and you don't get a public IP address, right? So how can I reach your house? That's kind of hard. And the same is true for all these other cases. How do I get actually onto that computer in the house? How do I get at my media? How can I go and control, how can I support a computer? Right? Support is a big topic. There's the CEO of a company is roaming around the world and wants to show a PowerPoint at the PowerPoint, and his PowerPoint, Microsoft Office PowerPoint is hosed for some reason. So a support engineer should be able to just connect to that machine, no matter where he is, and go and fix it. But how? So Service Bus is specifically built for that purpose. With Service Bus, even if at your house today you don't have a public IP address, you can host a service at your house. And because we have a listener in the cloud, that you can listen on, and we give you that traffic. So I'm going to show you the code for that in a moment. So what's Service Bus? Service Bus is a connectivity fabric. We're going to go and talk about the service relay. We have capability to do tunneling of protocols through samples, actually. So I have a sample that's on my blog called PortBridge, and PortBridge can create a end-to-end TCP tunnel between two places, whereby the target place may be sitting behind firewalls and NATs. So one thing that people use this for is they have some SQL Server on site, and the SQL Server speaks TDS, the Tabular Data Stream TCP protocol. And so with this PortBridge thing, you can have that listener sitting on site, and you can have an agent that's listening on port 1433 on the other side, and you can connect through Service Bus into that machine across firewalls and NATs. And we're not breaking the firewall, we're doing everything legally, and you opt into that entire model. You install the software, you run it. So it's a very intentional thing. We're not defeating the firewall in any way. We're just reversing the direction of traffic. And we're going to explain exactly how that works. Queuing, pops up, reliable transfer is on the messaging side. I'm going to talk about that towards the end. What we also have is a notion of naming, discovery, and we're going to add monitoring. We have integration. That's a piece that's owned by the BizTalk team. The BizTalk team sits in Hyderabad. So parts of Service Bus, including the integration pipeline, routing, transformation, coordination, is built here in India. And a lot of the push and pull capabilities that we're going to build are also going to be built in Hyderabad by our BizTalk team. So this is India. And it's great fun. So let's talk about the connectivity relay. That's the current capability. That's the thing that's shipping right now. So I'll triage this out. So the connectivity relay is the thing we've been shipping since January 2010. So you can use that in your apps. Some things I'm going to be talking later about, we are about to give out as a CTP. So this is existing. So how does this work? Your receiver and sender are services, and they live anywhere. They could live here, and if the network would be functioning at all, I could also show you that. And we assume that the sender is firewalled and the receiver is firewalled, and it's behind NATs. So, and the receiver now wants to be ready to receive messages. The way it does that is it creates an outbound connection to Service Bus and registers. So the receiver comes in here and registers at a name. Name is important because this tree here is a naming fabric. If you go and provision a namespace in Service Bus, that happens in the portal. Wow, I didn't want to do that, but I'm surprised that it's such a nice effect. So these are namespaces that I created. These are my actual real namespaces that I use. For instance, this one is one that I'm using for my personal purposes. So these are all namespaces. So any of these namespaces creates a projection into DNS. So you have clemensv.servicebus.windows.net. That's your anchor in DNS. So whenever you go and create a namespace through the portal, create a name in DNS for you. Off that name in DNS hangs a naming tree. And the philosophy in the naming tree is all the names that could ever exist already exist. So I can show you that. Well, maybe I can't, but let me just try. Browser. So let's go clemensv.servicebus.windows.net and hope for the network that it at least talks to me a little bit. It certainly is very spotty. Yes, it does. So that's my feed. That's the feed of all services that I have. Let's see whether I have one that I can go and actually see. Yes, so at least I have one that I can show you. So this is a thing I run at home. And I run a protocol tunnel on that. and I'm projecting, actually I'm running this at home, and I'm projecting multiple machines onto this same namespace. Those machines, one of those machines runs in Kirkland, Washington in the US. The other one sits in Mönchengladbach in Germany. And I'm projecting both of those machines into the same namespace, so I have a common surface for them. What I'm doing with that is I'm exposing things like RDP, so I can TS into that machine straight through that tunnel. And I'm exposing actually the German Deutsche Telekom proxy server, the web proxy server, through that tunnel, so I can surf from the US as if I was in Germany. So I'm tunneling that as well. And then I have some auxiliary additional services that I just project up into Service Bus. So you see the root of my namespace, and most of those things are hidden. You just see that intermediate thing because I kind of tend to see this, tend to show this. Now, mind this is vastorstv.servicebus.windows.net. You can't see that, so let's go and try to make that a little bigger. So now you should see that. So this is now my namespace. All names that can ever exist do exist. So let's go and say foo bar baz. And what you'll see is that also gives me a feed, but in that feed is nothing. So you can walk up to any name in that fabric, any name that's conceivable, and simply put something there. So that's what I'm doing on this picture. What I'm doing on this picture is I'm putting a listener into a name, and I just can pick the name, and all those names already exist. So I can go and pick that name, and if there's an intermediary node that needs to be created, I create it. What you also see, these are feeds, so these are all Atom feeds. So you can go and discover services by just traversing that hierarchy of feeds. So it's very simple discovery, and we're going to add actually queryability into this, so you can go and tag those, it's feeds. So you can have categories on them. So you can create your own categories, and you can go and query by those categories. That's something we're going to add in the future. But that's how the namespace works. So namespace is pick a name and put something there. The thing you put there is a listener or connection point, as we call them, or a message buffer, which is this little queue, or in the future, a queue or a topic. And I'm going to talk about those in a moment. So you create this connection. This connection here is a socket, and we keep that socket alive. If this thing gets disconnected for whatever reason, we reconnect. If the machine goes to sleep and it wakes up again, we reconnect. As long as that thing is open, we do whatever we can to go and connect back. If you move into an environment where the ports that we need, 9350, 9351, 9352, 9353, if those are not available, we will create a simulation of TCP through port 80. We take a long post, a long get that are using HTTP 1.1 chunking. We bundle them together, overlay the bundle with SSL, put some pipes and pumps around them, and take that bundle and snuck it under the NetTCP WCF channel stack. So we're effectively creating a TCP emulation over a pair of HTTP connections. So we're doing whatever we can to get out, as aggressively as we can. We even work. We've been working with the ISA team to make sure that we don't even get stopped by the virus scan that kind of runs on some of the downloads. So we do whatever we can to get out. Even if you're switching networking environments between putting your machinist to sleep and waking it up again, we will go and fall back to HTTP or optimize for TCP again. So now a sender comes in and wants to send you something. And I'm showing you the TCP path here. The sender comes in and creates an outbound connection. So you have a NetTCP relay connection, and that comes into our system. We now know, based on the address that you're giving us, right? The connection to channel has an address on it. So you go to your name, clemensv.servicebus.windows.net /foo/bar. So we see this, and now we're going to look up the machine of where that's connecting. All these boxes here are front-end machines that you can be connected to. So you come in to some completely different machine up here, and you connect to it. Then, what we're going to do is we're going to send a control message into the fabric and say, hey, I want to go and talk to that receiver, and then we're sending that control message down this pipe, this notification pipe, to the receiver, and then the receiver will go and rendezvous on that machine with that forwarder, and from here on, we have a pure byte array forwarder. That's for TCP. We have variations of this. For HTTP, we have a pure HTTP listener that sits up here, so you can come in with any HTTP client, and we're doing kind of half of this story, where you rendezvous to get an HTTP request. We have a multicast model, we have a one-way model, so various ways of creating those services. The way you opt into this is you just create a WCF service and you just use a different binding. So, using outbound connections only, no open inbound firewall NAT ports, outbound connections default to TCP, fall back to HTTP when needed. So, since I got connectivity, we can go and try. Maybe we're lucky. So now I'm going to do something really daring. And that is, I'm going to go to the portal. I will go to one of my accounts. Let's take this one. I will go and get the default key. Right, now you know all the secrets, Clemens v5. And now I'm going to take this app, I'm going to try to run it. I'm going to show it to you after I run it. I just want to know whether it works. No, you know my key. It's going to be a video. I have to change it anyways. It's not going to do you good for very long. Maybe it'll work. We'll let that run, and we're going to go and take a look at the code of what I did here. And you will find this is not a very ordinary service. So we have a contract. Some room here. A contract. It's just a normal WCF contract. No surprise. There's a service. All that does is effectively implementing that contract and returning echo back. And then we have an ordinary program that will go at the core of it. Basically, you're just going to create a service host that service, then do a little bit here with the service registry settings. I'm going to get to that in a moment. And it's going to add a behavior, the credential for service bus, into the endpoint, but then it's just going to open it. So that's nothing out of the ordinary. The secret here lies in the app.config, where we're using, instead of the regular NetTCP binding, we're using the NetTCP relay binding. That's really the secret of it. So this is exactly what EasyJet did. So they have an existing set of WCF services. What they did is effectively they flipped out the binding. So we have, for most of those bindings that you have in WCF, we have corresponding relay bindings, where you can now, instead of listening on the local machine, you simply listen up in the cloud. And with that, you take the traffic in the cloud, we take that for you, and then send that down to you using that mechanism that I just explained to you. That's the magic behind Service Bus. So you get all these capabilities for any service that runs anywhere. If we can get out with our connectivity magic, you can get traffic sent to you. And that's the great thing about this. So we have the service running. So it runs at Clemens v5.servicebus.windows.net/echo service. Wow. So let's go and see whether we can see it. Because I made this public intentionally. So let's go back to the browser. See whether we can see that here. Oh, well, that's not going to work, but we're going to see it enumerated. So there it is. So that's my echo service. I'm making a request here on the data center in San Antonio, and my service that I'm hosting from here is sticking its head out in San Antonio in Texas, taking traffic. So if we're really lucky, I can start the client.
that's not going to work. Let's try that again. Where was my secret? Come on. Thank you. So the service is running here. Client is connecting. Let's see whether it works. And if it's not, that's not so tragic because the network's so flaky here. Well, I'll come back to that eventually. So, but that's the magic of it. You can go and basically take an FCF service and just expose it on Service Bus, and it's super simple. So it's enormously powerful because all of a sudden, the internet is, if you look at it, really this finite space of hosts that are in the middle of it and are in possession of public IP addresses. But with this technology, you can go and expand that and now have all these machines that are sitting out in NAT and can talk to them straight away. And whenever you have the integration needs, right, the chewing gum, whenever you have that need, you can go and pinpoint services out of your environment and expose them onto Service Bus, and we'll overlay them with this access control capability, with the access control service, so that they are secured, and then you can use federated identity to go and integrate with them. Yeah, that's not cooperating with me, but that's not tragedy. So no open inbound firewall NAT port. So I was able to host a service, and I would be able to speak to it. Just need to believe me. Without me just doing anything to this network, I didn't speak to anybody. This is just wireless, right? That's secured with the access control service. It's pretty magic. So several things that people do with expanding on the scenarios that we have. One of them is eventing. One thing that we see, and they're using our multicast capability or our unicast capability today, where you have clients, and clients are either raising events into the cloud or applications in the cloud are raising events. And we have a number of clients, and so we actually have a sample for that, the Cloud Trace Recorder that's in the SDK, or in the SDK samples, that you can basically just hook up. It's a .NET diagnostics provider that takes all the traces that are emitted by an application and just throws them onto Service Bus. And then you can go and subscribe to a name and basically get all those events, and you can see live as things happen. So I do that all the time, so now we have an alternative with IntelliTrace, right? But it's an even more direct way of just hooking this in. You publish your events to a name, and you can go and subscribe, and you can see those things happening live as they happen. And it's a very great way for even multiple parties to go and hook up to an event stream and get them live. We're going to have a capability called Topics. It's going to have this also in a decoupled fashion, but that's a decoupled direct fashion here. So eventing is one pattern. Service remoting is something that we obviously see, and that's what the initial scenario was about. You have an e-commerce front end, you have an ordering system, you have an inventory and shipping system, and those may not be sitting in the same place. This may be in the cloud, this is in-house, this is outsourced with someone else. And you need to go and create that communication link between all those different parties without incurring all the cost of firewalls and NAT and management of all those things. And Service Bus, just take that service, just expose it out in the same place from multiple places, right? Even I do that at home. All my TV assets, see, I'm moving a lot of video around because we're Germans and we live in America and we want to watch German TV, so that's why I have the setup. I project all my services into one namespace. So I have, no matter where they are, I don't need to think about host names. For me, I think about endpoints, and I don't care what host they're on, right? I care about the individual service instance, but I don't care about the host where that lives. So I have complete agility between networks. I can have a service on my machine, and I can talk to that. As soon as the machine sits network anywhere, on some hotel network, I can talk to that machine. I don't need to know what its IP address is. I don't need to know its name. I just need to know the endpoint name, how it's projected into Service Bus. And the last thing that we have is tunneling, and that's one thing I told you. I would show you the demo, but then you would hack it. So, because I have my German proxy endpoint actually exposed out on the public internet, so I'm not going to show that to anybody. But this is what people do. We have examples of folks having SQL Server on-premise that they only need for a transaction or two. So they have a cloud app. The cloud app has all data that it needs to go and do all the work. It gets the data replicated. But at the end of all the work, it needs to run one transaction in a core database. So what people do is they basically take a connection to that database and pull it up. And they do that with this bridge. So this bridging technology is called Portbridge, and it's a free sample that's on my blog. And we're looking into the way how we can make this. The client has stopped working. The way we can go and integrate this into the product. So I think the first thing that you'll see eventually showing up in Service Bus is a native TDS endpoint, so that you can walk up to any name in the namespace, and you can create a SQL connection point. And the SQL connection point gives you a TDS head inside a Service Bus that you can hook any SQL server under. And then we'll have an extension in the SQL client that will allow you to specify that in the connection string. And that's going to be the first iteration of that. So we have pretty concrete plans to even hook into the SQL Server protocol stack to actually make that work. So that brings me to, so far, these are all things we have been talking about. Now, for the last, 10 minutes, I will talk about things we haven't talked about yet. So, we have a thing called the message buffer, and that's a little volatile queue, and that's the thing that EasyJet is using. It's in memory, it has a TTL of 10 minutes, so if you don't entertain it, it dies. It's kind of like this little Tamagotchi, I don't know whether you know that thing, or an Oracle database. So if you don't pay attention to it, it just keels over and dies. That's by design, because we want you to see this as a volatile structure. The maximum size of content you can have in there is 2 megs, so that's not a lot. And the maximum message size is 60K. The new thing we're going to introduce is called the queue. The queue has durable storage based on SQL Azure, no limit in lifetime. You create one and it's there. 100 megabyte as the starter size for the queue, maximum size for the queue. We're thinking about upping this significantly into the 1Z, 10Z gigabytes, 256K message size. With a mechanism for being able to create sequences of messages, so-called groups, where you can overcome that limitation and can have effectively messages of unlimited size that can be pinned to a particular consumer. So we're going to have a first-class real queue that sits inside a Service Bus in the cloud. Now you'll say, wait, so there's a queue already in Azure that's called the Azure Queue. How is that different? Well, it's different because the capacity is, the message size is different, it's larger. It's format free, so you can figure out what your format is. And we have PubSub capabilities, and we have special functions like receive by correlation ID. I mean, we have real messaging features inside of there. The Azure Queue is a job queue. So think about this as the same difference as name pipes in Windows, that's the Azure Queue, and MSMQ in Windows, that's us. And coincidentally, we own MSMQ. So we are the team that's owning MSMQ, and we're also owning this new technology. Why queues? And the veterans amongst you, I'm not telling any news, but it's a refresher for the young folks. Load leveling. I have a publisher, probably a website that has enormously spiky traffic. Goes up and down and up and down. But you really don't want to have that same kind of behavior pushing down onto the consumer, which is scaling to the average load, right? So if you have processing, you want to go and process orders, website e-commerce orders. It would be stupid to scale the backend system to the peak demand because you don't have to. What you do is you go and scale the front-end system to the peak demand, and then you take all the spikiness into queues, and then you process out of queues in a steady flow. You never cause that pressure to actually go into the backend. So that's decoupling to flatten that out. Next thing is load balancing. How do you get that work load balanced? You have a publisher, you have a number of backend processors. How do they get their work? Well, a consumer gets a message, works on it, goes off and does whatever it needs to do. When it's done, it comes back and gets the next message. So you have a predictable number of consumers, a predictable number of services that are competing consumers on this queue. You publish all the work in there, and just like a thread pool in memory, you get this pool of workers, and you can look at the length of the queue. And if the length of the queue goes longer than a certain threshold, you start adding workers. If the queue shrinks to a small, right, if it gets empty, you subtract workers. So you can go and dynamically scale up and down your backend workers based on the length of the queue, and that's a really interesting thing. Temporal decoupling. You have a publisher. The publisher sends messages, but the consumer went to sleep. It went to sleep in the I'm closing my computer kind of way, or it went to sleep in the I'm in a conference room in India kind of way that has no network. Or in the, we're not going to do processing on consumer banking statements until 12 at night kind of way. Because, as you notice, your personal bank statement doesn't get updated all the time. Because the bank has better things to do with their systems during the day. So your stuff ends up in a batch, and that batch is processed on some time. So the target system sleeps. So what you do is you batch a bunch of stuff into that queue, and once you're ready to free up your capacity, you wake up and you just get all that data and process it. So it's temporally decoupled, and that's also something that the queue gives you as a very nice thing. And then, of course, integrity. You have a queue, the queue stores that work, the consumer takes the work and now blows up. There's mechanisms called, and there's a very simple pattern called peak lock, that even without transactions you can leverage here to make those things really resilient, where you have a peak lock means you peak the message and you lock it. Now nobody else can see it, and now a clock starts ticking on that message. If you consume the message, so you work on it, you walk over to the queue and say, thank you very much, you can delete it. If you crash and burn, the clock releases the message, and then the message is there again. If that overlaps, all you do is you record the ID of the message you processed. If you see that thing again, you just throw it away. What that gives you enormous resilience against failures, and that's one of the things we do in the provisioning system internally. So in our enterprise system that we build. So queues, great for that. So our goal for Service Bus, for our queues, is to support all these scenarios. Now, if you think about balancing work with queues, ASP.NET Frontend. You can build this today on MSMQ, by the way, actually very elegantly. You have a work queue. The work queue is backed by the workers, just as I showed you in that pattern. Every frontend has its own private reply queue. So what you do is the ASP.NET frontend goes to the shared work queue, puts a message in there, and it says on the message property, it says the reply queue address. Right? It says, come back here if you have a message, and sends the message, and now it remembers the message ID that it just produced. That's the thread that sent that message. Now, the message goes, and you don't even know what target machine that goes to, because you don't want to have that pressure of the front end to end up here. So you sent that message, now you know the ID of the message that you sent. That's the so-called correlation ID. This guy will take the message out, will work on it. If it has a reply, it will go and look at the message and say, my reply address is the following, sends that to that queue, and sets the message ID of the message it processed to the correlation ID that it sends back. This thread sits on the queue and says, received by correlation ID. And that's how that thread gets its message back. As you hang on that thread, you set a timeout for that receive operation for, let's say, 10 seconds. If you time out, you tell your user, sorry, we couldn't get you an answer in time, but we'll be sure that we can do it, and then we're going to tell you later. And as the message arrives, then you can process that in the background. So you can do a queue-based system even in the ASP.NET world and decouple your systems in that way really nicely. Last thing, I know I'm going to run over by 2 minutes. I'm sorry. Is topics. I only have 3 more slides. No worries. And topics is really a version of this where you have a log, and instead of having one subscriber, you have multiple subscribers. Instead of having one cursor that runs over that log as in a queue, you have multiple of those. Which means you can now take one message and have it sent to many subscribers. Why would I want to have this? Event fan out. Message goes in, goes to everybody. Everybody can go and look at the message and filter it based on some conditions, based on properties that are in the message. You can have competing consumers, so you can have the queue pattern sitting up on the subscriber, or you have single consumers that get that message. One of those scenarios is, for instance, auditing, an audit tab, where you use a topic just like a queue in all the previous scenarios, but you have an extra subscriber that gets all the messages as they were in their original state, and you can go and tap them and put them into an audit log. So you always get a new message. Get the original messages logged into an audit log. So those capabilities are going to land in May in the brand new technology preview. So you're going to have topics, you're going to have those queues. I didn't show you the API, obviously, also because I ran out of time. And but we'll have that in video from TechEd, and you'll be able to see that API. I'm going to be presenting it. I'm going to have 75 minutes, so that helps actually with that time a little bit. And so then we're going to be curious what do you think about those things, and we're hoping to put this into production so you can actually use it in the second half of this year. And with this, if you have questions, still meet me outside after the session. And thank you for your attention. Thank you for having me.